Okay, so in this video, I'd like to have a more in-depth discussion of variable scope. The scope of a variable really determines the variable's visibility in a program, and where can that variable be used in a program. So for example, I have two functions here. This is just some function that I defined up above main, so I've skipped the prototype. And here's the main function in our program. And in this function, this sumfunc, we have a variable called sumVar, sum variable, okay? And it's an integer, I've set it to 0. The scope of this variable is limited to this function, meaning only this function knows this variable exists and can use it. We call this local scope. And so, for example, if I come down to main and I try to reference that variable, sumVar, the compiler is complaining. I get this undefined error. And that's the compiler's way of saying, well, what are you talking about? This doesn't exist here. So I think I said in an earlier video, if you imagine your program is like a house, and each function, each curly brace sandwich, is like a room in the house with the doors shut. Okay, and so when you're in a house and you're in your room with the door shut, you can't see into the next room. You can't see into other rooms. And so that's kind of how this is arranged. So when you have a variable created inside of a function, or even inside of a set of curly braces, really, the scope of that variable is local to that set of curly braces, or that function. And another thing I'll mention, and this kind of is setting the stage for the next video on static data, but the lifetime of this variable, of a variable of local scope, it basically only exists in memory while this function is running. So when this function is done running and we get to the end here and the function is done executing, this variable disappears. It falls out of memory, as we say, and it no longer exists. So local variables of local scope kind of have this short lifetime as well, or they only exist while the function that they're in is running. See, with main, this was never an issue. Main is a special function because it basically drives your whole program, and it's always running while your program is running. So even if we create a variable in main and it only has this short lifetime and this kind of local scope to main, it has never been an issue before because our whole programs were main, basically. So now it becomes an issue because we're breaking our programs up into more functions. So, and you know what? This is a two-way street. If I create a variable in main here and set it to some random value, okay, fine. Now I have a variable called x in main. If I try to go up here into sumfunc and change that value or even reference that variable, look, the compiler is complaining. Again, I get that undefined error, meaning, what are you talking about? This doesn't exist here. So you kind of always have to have this in the back of your mind. Now, we talked about parameters, and the parameter is a doorway into the function. So if I need to get a value from here in main into this function up here, you know how to do it at this point. You would parameterize this function and then pass a value into that parameter to get that value into the door here, into the door of that room, using my analogy. Okay, now I'm going to show you another thing here with regards to scope, and I'm showing you this with caution because this is something I really want you to avoid in this class. Let me create a variable here. Look at where I'm at. I'm in the white space. I'm not inside of any function here. So I'm going to create a variable up here. I'm calling it global var, global variable. This is a thing, okay? And I've created this variable called global var up in the white space in no man's land, so to speak. And watch if I try to reference this variable in main, for example. Okay, no problem. The compiler is quiet. Compiler doesn't care. How about in here in sumfunc? No problem. The compiler is not complaining. So as you can imagine, a global variable is accessible throughout the program. All right. And I want you to avoid doing this because, first of all, it's just generally speaking not good programming practice when you have a variable up there, like, kind of sitting on top of the world, so to speak. It's vulnerable and it's more easily corrupted, and it's just bad programming practice. As a rule of thumb, you should create your variables as locally as possible. But another thing, and this is more of an academic thing, is that if you have a global variable, you're going to be able to bypass some of the very important concepts we're talking about in class, such as parameterizing functions to pass data into functions, returning values from functions. If you have a global variable, it's accessible from all over the place, then you don't have to take these avenues, parameters, return values, and that's not acceptable. We need to show that we know what we're doing in this class at this point. So I'm not saying global variables are never ever used anywhere in the world. They are, but it should often be kind of a last resort, or it's not something you should do without putting a lot of thought into it. So they're not allowed in this class. Let's just lay down the law right now, and we are all going to avoid them in this class. And that's it.